Hello, Math 20-1. Um, the big learner outcome of 4.5 is graphing by completing the square. That should be familiar to you because we did talk about that in quadratic equations. Completing the square is a big idea from there. So how does that apply to this? Well, that's what we're going to find out. So, for example, at the very beginning of this unit, we asked you if you took your basic parabola of ax squared plus bx plus c. The problem with that form is that in that form, the only thing that you can really easily find out is I know that my y-intercept is equal to c. And that makes us kind of sad because we know that the vertex and the axis of symmetry and all those things are really, really important. So what we want to do is take something like this, y equals 2x squared minus, we might say 8x plus minus 8x plus 5, let's say, and we want to take that and we want to be able to know the vertex and the axis of symmetry. We want to be able to put it in what's called complete square form. And if we can do that, and I know you guys might think, well, I have a graphing calculator. That's not what pre-calculus is about. Pre-calculus is about us being the brains of the operation. So how, without using my graphing calculator, can I know the vertex and axis of symmetry and find out the exact x-intercepts and all those good things? That's what this is about. How do I do that? And it involves completing the square. We will use that skill again. All right? So we'll maybe come back to this question at the front of the slide and we'll have a look at this again. Okay? So the first thing you need to remember is, and we should remember this, so this is good review from what we talked about before. In Math 10, we talked about perfect square trinomials. And if you went to factor x squared plus 6x plus 9, that would be x plus 3 times x plus 3 or x plus 3 squared. If you think about in general what a perfect square trinomial is, it means that the factors are of the form either x plus a squared or x minus a squared. And we're only going to have plain x's right there, okay? No 2x or anything. We're just going to have plain x. Note the relationship between the middle and last term, that this middle term, if you took a half of it and squared it, you would get the last term. The last term is 1/2 of 6 squared. So in other words, it ends up being 3 squared, which is 9. That property applies to all perfect square trinomials. So for example, if you had x squared plus 14x, what would be the number that would have to be at the end to make it a perfect square? Well, clearly it would have to be 49 because 7 squared is 49. What would it have to be if it was a 7 in the middle term? Well, half of 7 is 7/2 squared is 49 over 4. That means that the perfect square would be x plus 7/2 squared. Lastly, what about x minus 3x? Clearly, if you divided minus 3 by 2 and squared, you get 9 over 4. That would give us x minus 3 over 2 squared. So this is a bit of a review of what we talked about in completing the square before. If we carry on to, move this down, if we carry on to changing from general form to standard form. So general form is, let's say we had something like x squared plus 10x plus 23. Oh, I know what we know. I know we know that the y-intercept is 23. That's great, but that's all you know. The y-intercept is 23. What is the vertex? What is P? What is Q? Has it been stretched? We need to know those things as well so that we can sketch the graph, right? From what we talked about in 4.4, right? So we need to put it in a times x minus p squared. So here are the steps. The steps are, we'll bracket the first two terms. So we put brackets right there. X squared plus 10x are bracketed, okay? It's going to be a little bit different than what we did in, it's going to be a little bit different because this is a quad function. It's not an equation. We're not going to move stuff on the left and right. All right, but we have to maintain this balance. The second thing we do is we add the value we need. To make it a perfect square, I need to add, what do I need? I need to add 25. But the legal thing to do is to subtract 25 at the same time. Why? Because in the end, you got to be able to get back to what you had, okay? You can't violate the fact that this is completing the square, okay? Next, you'll group the part you need for the perfect square trinomial. So you don't need this minus 25. That minus 25 has got to go, right? This is the part that you really want. You really want the perfect square trinomial, right? You don't want to have that minus 25 there. So you kick it out, right? You kick that out. Get out of there, right? 25 minus 25 is 0, but we'll kick it outside the brackets. Now I've got my perfect square group. There's my perfect square, right? And now I can factor like we talked about in the first slide. So I factor it, and when I factor this, I end up with x plus 5 squared. And minus 25 plus 23 is minus 2. If I graph that, we talked about that. Where's my vertex? Minus 5, minus 2. It hasn't been stretched at all. So if you needed to, right, if you had graph paper, if you needed to graph, let's just put another critical point there. I know at minus 5, minus 2, if I went over 1, I should be going up 1, 2. So this point right here would be minus 4, minus 1. And this point out here would be minus 6 and minus 1. Just in case we needed more than just 1 point. I know it hasn't been stretched, right? So those would be the exact points, right? Well, they're not all going to be that easy. Here's a little bit tougher one. This one is 2x squared minus 12x minus 11. Okay, sketch the graph of this. Okay, completing a square. I remember, what was the first step? First step was to bracket the first two terms. So we're going to put it from general to standard. I bracket the first two terms. Done. Okay. Next thing said, well, now we got to factor out. Oh, this one's different. This one doesn't just have a 1 here. There's a 2, okay? And you did this when you completed the square before. So I take that 2 and I factor it out. When I factor that out, I get 2 times x squared minus 6x minus 11. Great. Okay, I factored out. Third step was, okay, can you make this a perfect square trinomial? Make it a perfect square. So I need to divide by 2 and square it. What's the number I need? I need to have 9. But at the same time, I got to subtract 9. Why? Because I cannot just do something without, I can't change it. I have to basically add nothing. But I need the 9, so at the same time, I'll subtract 9. I can't have that minus 9 in there. I need to kick this out. Okay, so I'll kick it out, and I throw it out there, and therefore now I have to remember to multiply that. That really wasn't adding 9. It was really adding, if you remember, I'm just going to yak a little bit here. This really isn't x squared. It's 2x squared. This really isn't minus 6x. It's minus 12x. This really isn't 9. It's really 18. And this is really minus 18. Okay? So really, when you kick this out, you must remember that this is 2 times minus 9. Okay? And as you practice that in your formative work, that'll come into play. Okay? So now we continue on, and we, moving this down so we can see, and now we finish that off, and we, minus 18 minus 11, this has been graphed over at 3 minus 29. Okay, so it's a long ways down there. I do want to remind you, okay, I don't need my graphing calculator. If I was to graph another critical point, I know that if I went over 1, I would be up 2. So this would be the point 4 and minus 27. Why? Because it has been vertically stretched by 2. So in other words, my basic parabola, the basic parabola is no longer over 1 and up 1, it's over 1 and up 2. It has been stretched by 2. You need to remember your basic points of your parabola, okay? Good stuff. completing the square. Ooh, what are we doing now? What are we doing now? Well, not everything turns out to be integers. So you may not like this, but sometimes you complete the square and the vertex does not happen at an integer. So we follow the rules again. I factor out the -3. If I factor out -3, I bracket the first terms. I factor out the -3. I factor out that and I get -5/3. I divide by 2. Dividing by 2. Okay? Don't get freaked out. Dividing by 2, -5/3 divided by 2 is like multiplying by a half. That creates -5/6. Okay? So when we do that and square it, we end up with 25/36. Okay? So let me just remind you why. So -5/3 got multiplied by a half, and that's going to equal -5/3, sorry, -5/6. And so once you squared that, it became the number you were looking for, 25/36, and then you subtract it as well because you can't have just addition. You must basically maintain the integrity of this. So we add and then we subtract it. Okay? Now we finish off our work. We got to kick this out of here. Again, you got to like fractions. You got to multiply that by a -3. When you do, it can cancel off with the with the 36 on the bottom. So in the end, we get 75/36, multiplying by -3, positive 75/36. That fraction simplifies to 25/12 minus 12/12, because -1 is 12/12, and that simplifies to be -3 x minus 5/6 plus 13/12. When you complete the square for this one, it doesn't turn out to be integers, but the vertex is at 5/6 and 13/12. Okay? Your assignment would be this. Okay? Actually, follow whatever's in your formative sheet. Okay? But I did want to add one other thing. There's one other thing that becomes interesting about this method, and whether you ever use this or not is kind of up to you, but I did want to show you it. And there's something called the vertex formula, and we talked about using the person, the wise young math person, lady or girl that completed the square for a quad equation, developed the quad formula. If that same person were to complete the square for this quad function, here's what you get. If you complete the square for ax squared plus bx plus c, it looks a lot like the quad formula, right? So I'm not talking through this, but if once you go through all the work, what you get is a vertex formula. You get, what is the vertex of this? Notice the p-value. The p-value is minus b over 2a. The q value, what has this thing been shifted upwards by? 4ac minus b squared over 4a. So this formula is called the vertex formula. It's the formula that if you had something in general form, you could just plug in a, b, and c into this formula, and you would be able to find the vertex without completing the square. Kind of powerful, don't you think? So if you look at an example of how that might be used, a lot like the quad formula for quad equations, the vertex formula for quad functions can be used in an interesting way. Using the vertex formula, what's the vertex of this? You would have to complete the square, whereas this person simply goes, oh, I know what the x value for the vertex is. I plug in b and a, and I get minus 12 over 2 minus 4. The x value for the vertex is minus 3/2. And the y value for the vertex, when we go through that work, 4ac minus b squared over 4a, ends up being 14. And it saves you the work of completing the square, right? Boom. The vertex is minus 3/2, 14. Therefore, there is a maximum of 14 when x equals minus 3/2. And the reason we know that is because this is a sad parabola, minus 4, okay? Little joke for the end of the day. I wonder why the baseball was getting bigger, and then it hit me. Have a good day. come to class with your questions about completing the square.